Welcome to this explainer. Look, when it comes to Cambridge computer science, you've got to treat it like a boxing match. You need to float like a concept and sting like evidence. Jab, cross, hook. Those are your answer combinations. Today, we are stepping into the ring and unpacking exactly what Cambridge examiners are looking for when it comes to Ipv4 and Ipv6 formats in the Computer Science 9618 syllabus. Whether you're building your foundational knowledge from the 0417, 0478, 0983, 0984, or 2210 syllabuses, or you're right in the thick of A-levels, today, we're hitting the heavy bag with 9618. If you've ever stared at a past paper question about IP addressing, completely frozen, wondering how to structure your answer to get maximum points, well, you are in the exact right place. We see two types of students all the time. Let's call them Alex and Sam. Now, Alex overloads the answer with raw memorized computer science fact, but absolutely zero analysis, just a massive brain dump. And then there's Sam. Sam rushes the paper, panics against the clock, and completely misses the command word requirements. We're going to make sure you don't end up like Alex or Sam. We're going to break down the theoretical foundations, the technical methodology, and most importantly, the exact examiner insights that separate average, middle-of-the-pack responses from top-tier, knockout grades. Let's get into it.
Right off the bat, did you know that mastering this single topic accounts for approximately 15% of your total marks in Paper 2? Seriously, think about that for a second. 15%! That is a massive chunk of your overall grade, resting squarely on your understanding of how IP addresses function, how they are formatted, and how they are applied in practical computer science scenarios. We aren't just talking about a passing one-mark definition here. We are talking about a critical pillar of your exam success. If you bomb this section, you're starting the fight with one arm tied behind your back. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Getting those notifications means you get the strategies first. Okay, let's keep moving. Because this topic carries such immense weight, today we are going straight inside the examiner's playbook. I'm going to show you exactly what examiners look for. We've dug deep into the principal examiner reports for the Cambridge 9618 syllabus, literally reading through thousands of notes to find out precisely where students like Alex and Sam are dropping easy points and how the highest scoring candidates are securing their marks. My ultimate goal today is to give you a success blueprint, ensuring you capture every single one of those available marks when exam day finally arrives. No guessing, no hoping, just pure strategy.
Here is our agenda for today's session. First up, the 15% secret. Second, the procedural framework. Third, principal examiner warnings. And finally, the deconstruct, solve, evaluate method. Okay, round one, section one, the 15% secret, mastering core concepts. Before we can solve those brutal algorithmic problems, we have to look at the conceptual framework. Now, Cambridge isn't just testing your rote memory. They are specifically targeting three distinct cognitive domains. Think of these as your jab, your cross, and your hook. First is knowledge and understanding, the jab. Do you know the actual formatting difference between the 32-bit dot decimal structure of Ipv4 and the 128-bit hexadecimal structure of Ipv6? Can you define zero compression? But listen, it doesn't stop there. The second domain is application to scenarios, the cross. And the third is critical analysis, the knockout hook. Top-performing students must show a connected understanding of these formats that transfer seamlessly to completely unfamiliar networking contexts. You can't just memorize the textbook like our friend Alex does. You have to analyze the specific network given to you in the prompt.
Moving on to round two, section two, the procedural framework, earning method marks.
This procedural framework right here is the absolute secret to locking in your method marks during the exam. Examiners actually award points for your systematic process, not just the final correct number. When you are given data interpretation tasks, like extracting an IP address from binary representations or performing subnet calculations, you must faithfully follow this standardized sequence. Rule number one of our ultimate exam system, command word decoding. That's step one here. Identify the key elements and exactly what the command word is asking you to do. Second, apply the relevant principles of Ipv4 or Ipv6. Third, execute your analysis with clear step-by-step working. Don't do it all in your head. Fourth, verify your results. And finally, step 5, present your answer in the appropriate format. This is where rule number 2 comes in, Peel framework application. Make your point, provide evidence, give your explanation, and link it back to the question. Skip these steps and you are literally leaving valuable marks on the table. So how do we apply this standardized sequence to the algorithmic phase of IP addressing? You need to systematically break the problem down into 4 distinct phases. You start with decomposition.
a step-by-step breakdown of the networking task. Next is selection, where you choose the appropriate data structure to handle the specific IP formats, like maybe an array for IPv4 octets. Then comes implementation, requiring you to write efficient code. And finally, testing, where you perform rigorous checks of your implemented solution to catch any bugs. Following this specific structure is what turns a confusing programming question into a point-scoring machine. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's step into Round 3, Section 3, Principal Examiner Warnings. Don't lose easy marks.
It's one thing to know what to do, but it is equally vital to know exactly what goes wrong for other students. Remember our friends Alex and Sam? Straight from the Cambridge Principal Examiner reports, here are the top 3 ways candidates lose marks on this topic. Number 1, confusing cause and effect when explaining IP routing or addressing protocols. This is classic Sam, rushing through and mixing up why a subnet mask is used versus what it actually does. Number 2, forgetting to check boundary conditions in edge cases. This is a massive pitfall when testing the algorithms we just discussed. What happens if an IPv4 octet is 256? If you don't test for that boundary, you lose the mark. And number 3, the absolute biggest trap which Alex falls into every single time, providing generic, out-of-context answers.
Let's look at that third major mistake by comparing 2 approaches directly. And let's make this an interactive challenge. Imagine a question asking why a hospital network should upgrade to IPv6. A classic mistake, Alex's mistake, is just dumping a generic, memorized textbook definition of an IP address onto the page. IPv6 has 128 bits and uses hexadecimals. Okay, you might have the technical definition perfectly correct, but you will still lose the analytical points. Why? Because the examiner explicitly requires your answer to be context-specific. Every single point you make has to tie back directly to the specific scenario provided in the prompt. You need to say, the hospital should upgrade to IPv6 because the 128-bit structure allows for a vastly larger number of unique addresses, which is essential for the hospital's growing number of individual IoT medical monitors and smart beds. Boom! That's the Peel framework in action. Point, evidence, explanation, link to the hospital.
Now, I know what you're thinking. In the pressure of an actual exam room, it is so incredibly easy to panic, fall back on memorized definitions, and completely forget the context. To avoid falling into these common traps, I highly recommend creating your own personalized memory hack. Try creating a mnemonic using the first letters of key IPv4 and IPv6 terms combined with our standardized sequence steps. Having a quick mental trigger, your own secret combo, will help you stay focused on the process and ensure you don't miss those edge cases or contextual links when the clock is ticking down.
All right, final round. Section 4, the Deconstruct Solve Evaluate method, securing top grades.
This is where all our previous strategies build into the higher order evaluative thinking that truly secures top grades. To ace the critical analysis portions of Paper 2, especially when comparing IPv4 to IPv6 or evaluating different implementation approaches, you must use this specific method. And this brings us to rule number 3 of our system, the time management matrix. You have to budget your time to hit all 4 of these steps. First, identify the given information and consider multiple alternative solutions. Second, systematically analyze the trade-offs of each approach. Third, check for reasonableness and explicitly acknowledge the limitations of your proposed solution. No network is perfect. And fourth, always make your final recommendations and justify your decisions with solid evidence-based reasoning. This is your knockout punch. This is what the highest scoring candidates do consistently to walk away with those top marks. So, as you walk away from this explainer and prepared for your next past paper, I want you to ask yourself a serious question. When you see that next networking problem on IP formats, will you panic and fall into the trap of a generic, memorized response like Alex? Will you rush it like San? Or will you apply this procedural framework, decode the command words, use the PL framework, link your knowledge to the specific context, and secure every single method mark available? The strategy is now completely in your hands. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here. Keep learning, stay structured, and I'll catch you in the next one.